Welcome to the course, A Foundation for Machine Learning and Data Science, section Probability Overview. In this section, we will be reviewing what is probability, the language of probability theory, what is a probability tree, what are the different types of probability, why do we need to learn probability. What is probability? Probability is a subfield of mathematics that quantifies uncertainties. It deals with the likelihood of occurrence of an event, such as how likely something is to happen. Probability value can range from 0 to 1, that is, 0 is an impossible event, 1 is a certain event, and anything in between is a possible event. Probability of all the events in a sample space will add up to 1. Examples: predict the outcomes for the tossing of a coin, or rolling of a dice, or drawing a card from a deck of cards. Probability formula. Probability E is equal to the number of favorable outcomes of E divided by the total number of possible outcomes S, and the notation is P of A is equal to N of E divided by N of S. Examples: tossing a coin. What is the probability of getting a head? S is equal to head or tail, that is two possible outcomes. Therefore, P of H is equal to 0.5, that is 50% chance. Rolling a dice. What is the probability of getting a 3? S is equal to 1 or 2 or 3 or 4 or 5 or 6. That is 6 possible outcomes. Therefore, P of 3 is equal to 0.17, that is 17% chance. Drawing a card. What is the probability of getting a king? S is equal to 4 kings in 52 cards, that is 52 by 4, that is 13 possible outcomes. Therefore, P of king is equal to 0.08, which is 8% chance. I would like to explain the language of probability theory with the terminology used along with the definitions and examples. Trial or experiment, a series of actions where the outcomes are always uncertain. Examples: tossing a coin, rolling a dice, drawing a card from a deck of play cards. Outcome: a possible result of an experiment. Examples: tail is a possible outcome when tossing a coin. 6 is a possible outcome when rolling a dice. Event: a single outcome of an experiment. Examples: getting a head while tossing a coin. Getting 3 while rolling a dice. Favorable outcome: an event that has produced the expected outcome. Examples: while tossing a coin, expecting head and getting head. While rolling a dice, expecting 6 and getting 6. Sample space: the set of all possible outcomes to occur in any trial. Examples: tossing a coin, sample space S is equal to head or tail. Rolling a dice, sample space S is equal to 1 or 2 or 3 or 4 or 5 or 6. Sample point: one of the possible outcomes. Examples: in a deck of play cards, 6 of diamonds, queen of hearts. Complementary event: the non-happening events. The complement of an event A is not A, denoted as A apostrophe. Examples: in a 52 play card deck, A is equal to draw a diamond, A apostrophe is equal to do not draw a diamond. Impossible event: an event that cannot happen. Examples: in tossing a coin, it's impossible to get both head and tail at the same time. In rolling a dice, it's impossible to get 0 or 7 or any number that's not in the dice. Equally likely events. Events that have the same probability or chance of happening. Examples: getting head or tail in tossing a coin, getting 3 or 6 in rolling a dice. What is probability tree? A probability tree is a tool that helps to organize and visualize the possible outcomes. Let's see a couple of probability trees with illustrations. When we toss a coin, we have a half chance of getting a head and half chance of getting a tail. When we roll a dice, we have 1/6 of a chance of getting any number from 1 to 6. The forks are called the branches. The chances are called the probabilities. The outcome is called an event or a sample point. Tossing a coin or rolling a dice is called a trial or an experiment. The set of all possible outcomes of an experiment is called the sample space. Types of probability. Broadly, probability can be classified into 4 categories. The first category is classical, also known as theoretical, also known as a priori. The second category is empirical, also known as experimental, also known as a posteriori. The third category is subjective, and the fourth category is axiomatic. How does the classical probability work? Perspective. Experiments where the probability of all the outcomes will be equally likely. Examples: tossing a fair coin, both head and tail will have half possibility. Rolling a fair dice, all 6 numbers 1, 2, 3, 4, 5 and 6 will have 1/6 possibility. How does the empirical probability work? Perspective defines the probability via a thought experiment. Examples: if a coin is tossed 10 times and head is obtained 7 times, then the experimental probability is equal to 7 by 10, which is 70%. If we roll a fair dice 100 times, 10,000 times, 1 million times, etc., then we will get a better approximation of probability distributions among the numbers. In this case, any one number, 1 or 2 or 3 or 4 or 5 or 6, can have more possibility than the other numbers. If we roll a weighted dice, all the numbers will not have equally likely possibility because the dice is not fair. Empirical view is used in most statistical inferences and hence in machine learning. How does subjective probability work? Perspective. Probability is an individual person's measure of belief that an event will occur. Examples: an investor may have an educated sense of the stock market and intuitively guess the probability of a particular stock going up next week. A fan of a sports team predicts that a particular team is going to win the game based on his or her decisions on the team's past wins and losses, and what he or she knows about the opponent team as well. How does the axiomatic probability work? Perspective. Probability is any function from events to numbers satisfying 3 axioms, that is, rules or conditions, unifying classical, empirical, and subjective types. The axioms are: number 1, the probability of an event is greater than or equal to 0 and less than or equal to 1 for every allowable event. Rule number 2, the certain event has probability 1. Rule number 3, the probability of the union of mutually exclusive events is the sum of the probabilities of the individual events. Examples: rolling a fair dice. All 6 numbers 1 through 6 have 1/6 possibility and they are mutually exclusive. If we sum up their probabilities, we get 1, which is a certain event. Applications of probability. Risk assessment in industries. Example, what is the chance of the product be successful, or will the customer leave? Weather forecasting. Example, what is the chance of raining today, or what is the chance of the cyclone hitting India? Share price rise. Example, what are the chances of rising the share values of company A? Sports prediction. Example, who will win the World Cup this year? Politics. Example, who will win the presidential election this time? And the list could go on. Why do we need to learn probability? Like statistics, probability is also generally considered a prerequisite to the field of applied machine learning. Probability is also considered as the bedrock of machine learning. Classification. Classification predictive models predict a probability of class membership. Algorithm designs. Some algorithms are specifically designed using probability, such as naive-Bayes, linear regression, and logistic regression. Algorithmic decisions. Learning algorithms make decisions using probability. Model training. Models are trained under probabilistic frameworks such as maximum probability in Bayesian and k-means clustering. Model refinement. Model hyperparameters are configured with the probability such as k for k nearest neighbors, learning rate for neural networks. Model evaluation. Models' prediction skills are evaluated with the probabilistic measures. Evaluation metrics such as Breyer score, receiver operating characteristics, area under curve, precision recall curve, and the list could go on. With this, I'll conclude this video and I'll see you in my next video, Object-Oriented Programming Overview.